Okay, so thanks, Bill. We can start. Short marketing slide. We must hurry up a little bit. We are mainly only doing Oracle security, and up to now we found more than 350 vulnerability in Oracle products. And at the moment we have 50 open security bugs in different versions of Oracle available. The oldest, still unfixed bug is from 2003, and I hope Oracle will fix this sooner or later. In this presentation, you will learn how to disable security features like bypass features like database vault, virtual private database. You will learn how to run operating system commands by creating a table containing an exclamation mark IM minus IF. That's possible in some cases. You will learn how to abuse features like transparent data encryption, anti-forensic tricks, and so on. Before we start, a little bit Oracle basics. I'm not sure if I give presentations, most of the attendees are not experts, so I do 2-3 minutes a recapitulation how to hack unprotected database. Because from my experience, most of the databases out there are unsecure, and normally you don't need these advanced tricks to hack databases. As a rule of thumb, 8i, 9i databases are less secure than 10G or 11G. And the most common problems in Oracle are unsecure 8i, 9i TNS listener, weak or default passwords, missing Oracle security patches, and unsecure customer and third-party code. And for all these most typical problems, Oracle is not responsible because it's the task of the customer to do this. On the other hand, it's not so easy to change the passwords, to apply the patches, because it takes time, so it's not necessary in Oracle. The biggest problem in the meantime is custom code from the customer or third-party companies, because Oracle invested a lot of time to make the Oracle packages more secure. They're not 100% secure, and even in new databases like 11G, there are vulnerabilities, and they are easy to find. For the next few slides, I compiled everything in a small PDF file, so with 5 pages you have everything to hack most of the databases out there. Okay, that's a problem if you export stuff. Here there are 2 charts a chart how to hack Oracle unprotected database, how to do this without having a user account, and another way, if you have a user account, how to do privilege escalation and so on. And you find this everything on the Hack in the Box webpage or on my webpage. Here it's quite small. Here are the typical commands what you need if you are not so familiar with Oracle. For example, how to decrypt some of the Oracle passwords which are stored in the table, because in some cases Oracle is not hashing the passwords, in some cases Oracle is encrypting the passwords. And Oracle is so nice, I have no idea what encryption algorithm they are using, because there's a small function called decrypt. And what I did, I said, select decrypt password from table, and then I get everything in clear text. So it's quite nice. And there are also some links. Then some typical statements, how to get version number, if patches are applied, everything you need as a penetration tester, if you are not so familiar with Oracle. Here are some basics. Typical, if a listener is unprotected in 8i, 9i, in 10G, Oracle changed this behavior and it's no longer working. The typical behavior attack is, first you change the name of a listener log to a file like .rhost or glogin.sql. Then you put statements like set term off, grant DBA to hack in the box, identified by hack in the box. This command creates the DBA user with this password. Then you can run some operating system commands, and this content is written in the glogin. And the next time a script is started on the database server, the SQL script, these commands are executed. Because it's on the database server, in the server account, this is executed with DBA privileges. So without having a user account, this is possible. That's not a bug, it's just a feature of unprotected listeners. So you can just change the configuration and then you're protected. The next big problem, which many databases are still vulnerable, is a problem in the login process. If you log in against the database, Oracle is setting the national language settings with a command alter session set NLS. And this command was executed with sys privileges. So independent what account you're using to connect to the database, alter session was executed with DBA privileges. What I did, I just replaced the statement with grant DBA to public, and then you have democracy in the database, everybody's equal. Because everybody can execute everything. A few months ago, David Litchfield released a small tool called Aura Out Alter Session, and with this tool, it's no longer necessary to patch DLLs, you just call the tool with a few parameters, and then you can escalate your privileges. There's a patch available since 2006, but from my experience, many databases out there are still attackable. And all databases from 7 till 10G release 2 are affected if the patch is not applied. Next critical issue, everything is standard stuff. So normally every hacker or every skilled hacker knows this or should know. In Oracle, there's a concept called inline view. And the problem since Oracle 7 or since Oracle 8, there's a problem with inline views, and Oracle is confused with the privileges. So if you have only select privileges on a table, you can use a special crafted inline view to insert update data. And this is one of the examples. You have insert into, and instead of using a table name, you can use a select statement. And if you use the same table twice, so if you have a self-join, then Oracle is confused with the privileges, and read plus read becomes write. And I found and reported this bug. Most people underestimate the power of this privilege. For example, let's assume you have a reporting system, and some of your reporting users have only read privileges. Using such a special view, you can insert, update, delete everything. And there's you need no special privileges because every user with create session can run an inline view. For update, it's the same. So select combined with an inner join, the same table, and then you can update this. This was patched with October 2006 CPU. But in this entire concept, there were multiple vulnerabilities. And 2 months ago, in July, Oracle fixed a similar vulnerability by creating a special crafted view, again with using the same table twice. For example, you use the dual table and the dual table again in a subselect. If you use such a view, you can insert, update, delete via this view. And if you're a little bit more familiar in Oracle, there's a dedicated table called dual, and this table contains normally only one row. And every application expects that this table contains only one row, because you need this for counting and something like this. By using this view, it's possible to delete or to insert a second value. In this case, Oracle returns the same value twice, and your database will not work properly anymore. And up to Oracle 10G release 1, every user with the connect role has the right to create a view. And this was patched with the July CPU mid of July. Then some basics, how to do privilege escalation. Normally, in the beginning, it was necessary to have a procedure, and you created a procedure, F1, and you use the parameter outID current user. And in this case, this procedure is executed with the privileges of the caller. So if user sys is calling this procedure, sys is allowed to do this grant DBA to public and the function is working. If you are an unprivileged user and you try to call this function, you get the error message, insufficient privileges. So the first step of the exploit is creating this function. And in the next step, you are executing a procedure, and here you inject the function we created before. And this function f1 is executed as user sys. So user sys is allowed to do privilege escalation, and after running this, you have DBA privileges. So this was the old syntax. This was necessary to have a create procedure privilege. And at the Black Hat Federal this year, David Litchfield came up with a new idea using DBMS SQL. The big advantage of this approach, you don't need additional privileges. The idea is you create a cursor, a precompiled statement, and this precompiled statement returns a number. And this precompiled cursor can be executed with the command dbms sql.execute, and then you pass the number of the cursor. Because even if you open a cursor and if you don't close the cursor, it's still visible. And here it's similar, and one equal dbms sql.execute, and then you execute grant DBA to public. And this is the basic technique which can be used to become additional privileges in Oracle. Not only with Oracle packages, also with self-developed custom packages. And after running this exploit, a nice trick is to run the command zroll DBA. In this case, your current session becomes DBA privileges. And if you revoke DBA immediately from public again, your current session has DBA privileges, but it's no longer visible in the privilege table in the database. So even if you run a check who has DBA privileges, you don't see that the current user has DBA privileges because it's only on session level. That's the same exploit with some IDS evasion. Here I'm using the translate command to do a simple Caesar encryption. And here, this in red is grant DBA to public. If you have an intrusion detection system like Snort, you can bypass the check. So this is the end of the basic stuff. Now we are coming to the more interesting things. You saw there are a lot of possibilities to hack an unprotected, unpatched database, and applying security patches if you have default passwords is also a waste of time. Because in many databases you can connect dbsnmp/dbsnmp, and then you have everything. But there are some customers, they are hardening their databases. They choose strong passwords, they apply the patches, and so on. And even then, it's possible to hack the systems. And in the next slides, I will show how it's possible to do this. There are always mitigations and possibilities how to reduce this risk. But you should think about it. Probably the easiest way to hack, protect the database with super strong passwords, auditing, and so on, is the workstation of the DBA or the developer. It works for all databases, and it's not a vulnerability, it's a feature. You don't need username or password or credentials. And typical attack vectors is you use a USB U3 stick, or you have a browser exploit, or you have physical access to the workstation of the DBA. Most of the database attacks are done by insiders. For example, during the coffee break, someone sees that the PC of the DBA is not closed, not locked, and then he can modify a file. And the simplest way to do this is a file called glogin or login.sql. This file, everything in this file is executed after logging in against the database. For example, if you put the drop user system cascade in the glogin file, if you connect to the database after the DBA provided his credentials, Oracle is executing everything in this file, and if there's a command drop user system cascade, Oracle will dropping the user system using the accounts, the credentials from the DBA. Oracle is so nice to have even the possibility to call HTTP and FTP commands from the glogin. So if you put HTTP call in glogin, SQL Plus downloads the content of this web page and executes the content of this web page against the database. And that's not only an Oracle problem. There are other tools around, like Toad, SQL Developer, PLSQL Developer, and sometimes even SQL Server databases are affected. And the reason is the third-party developers try to make it convenient for DBAs. And if you work the entire day, you can create a startup file and put everything you need in this file. But there's no check or digital signature that nobody is modifying this. And here's what you can do. We insert into glogin.sql the string setTerm off. With this, we are disabling the terminal output, so the entire feedback is no longer displayed. Then we grant DBA to MTSys to a username identified by password. And if you use the grant command in this way, with this identified by, you create a user. It's not necessary to use the create user command. And then we enable the terminal output, so the DBA sees his normal login. So the DBA connects to the database, and in the background, a backdoor is installed. If you put the HTTP call in it, Oracle downloads the file, and in this case, we can even run. In this case, we download first a file called evil.exe somewhere from this IP address. Then we execute this on the workstation of the DBA. After that, we create a hacker, and then we give the privileged control back to the DBA. And this file is executed against every database the DBA is connecting to. So within 1 or 2 days, you have backdoors on every of your databases. I talked with Oracle about this problem because there's no possibility to disable this file. And the opinion of Oracle is every DBA and developer knows the glogin and login.sql. And before starting his computer in the morning, he looks up if the file is modified. And if the file is modified, he's not connecting to the computer. And if everything is okay, he starts working. I never met a DBA doing this. Many DBAs even don't know that this file exists. That's a new thing I'm presenting here the first time. It's how to put shellcode into database objects. And this affects not only Oracle, it's a generic problem, but in Oracle you can do sometimes a little bit more. It's possible to put different shellcode into database objects, like tables, columns, and so on. And sometimes this is executed. Normally a database object, in Oracle at least, is limited to 30 characters, so we need short shellcode to do this. And nowadays, most of the DBAs, or most of the DBAs and developers are creating objects using this syntax, create table orders. And in this case, Oracle converts the name to uppercase, and then the object is created. But according to the SQL standard, it's also possible to use special crafted characters, like single quotes, exclamation marks, and so on. For example, it's possible in double quotes to use create table orders with a capital D, and a column with a capital A and a lowercase a. And in this case, the table name contains an uppercase and a lowercase. What happens, for example, in many applications if you do something like this? This is a valid table name, and it's according to the standard. You say create table, and then you say script alert high script. Some web applications try to display. For example, this is a bug from DBA Connect web application, which is able to show tables. And they're not doing input validation or output validation. So a window pops up with this JavaScript. Because in many cases, table, column names, and so on are displayed. So you should never trust a database Normally there's a rule, never trust user input, but you should also never trust database input. There's one. I have no idea what this means. Okay, thanks. I mentioned that we are limited to 30 characters. This can be bypassed in some cases. Very often you have something like this, select table name, then a hard-coded dot in the middle, and then the column name. And in this case, we can use longer shellcode if we use the command sign. So we have script alert / star starts the command, and with this, we are commenting out the dot. And then our column name needs the second part of the command. And then Oracle is executing select script alert, and here we are commenting out the dot, and we have one JavaScript, which is longer than 30 characters. Instead of using shellcode, we can also use SQL code. You remember this function which allows us to become DBA? It's possible to create a table called single quote or 1 equal user12.f1 minus minus. It's a valid table name. And in some cases, this code is concatenated and executed. And then execution again, you get DBA privileges. Same game. Another big problem is the way how DBAs are working. If you are working the entire days, you have normally scripts to do the normal stuff. And in Oracle, most DBAs are using SQL Plus scripts. And a typical way how to create dynamic scripts is to use the spool command to create a file, and then you create a temporary file which is automatically executed. So we see here, we create a file count all. Then this is our dynamic statement. We say select table name from all users. Then we disable the terminal output. And then using the @ sign, we are directly executing the script we generated here. But I never saw a SQL script from DBAs doing an input validation. If you are now including shell SQL code in this table name, Oracle automatically removes the double quotes and our shell code is executed. This means most of the SQL scripts are vulnerable against SQL injection. And if you search on Google, for example, for spool on, spool off, select term and off, you get a huge list of scripts where DBAs are describing how to do maintenance jobs, for example. And you see the number of hits, it's quite huge. And if you go through the list, I never saw a script with doing input validation. So if you create this table, scott.emp, and somewhere in the script we have a delete from table, we have this select statement, delete all tables from the user hack in the box. Oracle is executing instead delete from scott.emp. So we are deleting other people's data. It's even possible to create an object which creates in the background a new DBA user. And how to do this is the grant command. In Oracle, there are two ways to create a user. One is with the create user command. The second is using the grant command. And as soon as you have identified by at the end of the grant command, Oracle is creating a user if the user does not exist. What we are doing now, this is also a live example from Oracle itself. we create a role called dba2x identified by h in the box minus minus. That's also a valid role name. And this is, I reduced the syntax, the script a little bit. This is a script executing during an upgrade. Select policy name, so we get a list of all the policy names or the role names. Then we convert our role name to uppercase, and then we append the underscore DBA. And the idea was to grant all the roles to the user sys. But by using the following role name, Oracle is executing grant DBA to x identified by h in the box minus minus. The underscore DBA to sys is not executed. And that's one of the ways we can create a DBA user just by creating a special crafted role name. It's a slow attack, so we must wait until the DBA is executing some standard command. The last thing, we can also execute operating system commands. So it's possible that we create a table !ein minus -rf/, and in some special scripts, this operating system command is executed. It's rare, but it happens from time to time. And the reason is SQL Plus has a command called host. And with host, it's possible to run operating system commands from within SQL Plus. And if you start SQL Plus on the server for a daily job or maintenance job, this host command is executed on the database server. If you start SQL Plus on your client, the operating system command is executed on your client workstation. So it depends where you are executing scripts. Instead of using the host command, there are two shortcuts, the exclamation mark and $sign. So for Windows, I have no idea why it's the dollar. Probably, I have no idea. And for Unix, the exclamation mark. So if we run $calc, calc is started. If we run exclamation mark ls, this is started and a temp file is created. Same game, Google. DBMS output can be used or spool off. And here you see not so popular, but even 30,000 hits in Google. And that's a typical script which is used to do a backup. And in this backup, you are executing the host command. Then you concatenate the backup command, which is a variable copy, and then you concatenate the file name without doing input validation. So by creating a file name with this syntax, you can run operating system commands. And after creating the script, it's automatically executed, so the DBA has normally no chance to review the script if everything is fine, and that's it. What can we do to mitigate this risk of shellcode in the database? Do not trust user input. Do input validation for scripts as well. The disadvantage, a simple script of 2-3 lines, which is inconvenient to write, is suddenly 10 times longer. You can check your database for potential shellcode like exclamation mark, minus minus, single quote, $sign, and so on. And here are some SQL statements. So we can search for, show us all tables and users with a table name containing minus minus. In most cases, you will see nothing. Sometimes you see the $sign or the $sign. But this is not necessarily an attack. And we must do this for every object. So we must do this for indexes, triggers, columns, and so on. Another possibility in Oracle, there's a concept called DDL trigger. So whenever someone creates an object, it's possible to run PLSQL code. And before here, this is a DDL trigger.
So we say before creating a DDL statement, we are checking if the dictionary name contains a minus minus or an exclamation mark. And if this is the case, we are sending an alert or whatever to the DBA. So using this, you can at least mitigate the risk. Now we are leaving shellcode in database objects, and we are going to auditing and some anti-forensics. Nowadays, most of the databases are not using auditing. From my experience, I would say less than 5%. Because auditing, most of the DBAs believe auditing costs performance. But if you use a only small piece of the auditing, it's possible to do auditing on every database. If you have a hardened or important database, a lot of people are using auditing. So it's a problem a pen tester should know. During the preparation of this presentation, I found a simple way to bypass Oracle auditing completely. So it's possible to run any statement, and even if auditing is enabled, nothing is audited. And this is normally the nightmare of every compliance manager or auditor, if you can change the salary of someone else and there's no entry. Oracle is informed, but no information so far because I do responsible disclosure. And I hope Oracle will fix this within the next 6 to 12 months. For performance reason, if you create audit information, in most cases, nobody is evaluating this information immediately. In most cases, people wait every 5 or 10 minutes. Sometimes, if you are paranoid, every 5 seconds, you are checking if there's a potential attack, and in this case, you do something. That's why it's important to be fast as an attacker. If you are able to remove all the traces you did during the attack within the first 5 seconds, you will be undetected in most of the cases. At the moment, Oracle Forensics is quite popular, and Paul Wright and David Litchfield released some forensics white paper, and David mentioned also a little bit anti-forensics. And the summary is, if you are an attacker, you are normally typically deleting the audit log, the fine-grained auditing log, and even if auditing is not enabled, Oracle is documenting some of the SQL statements, for example in this table, so it's a good idea to remove the information here as well. Then you can purge some other tables and flush the memory. The problem, if you wipe out the entire log file, this is obvious, because many DBAs detect that this information is gone. So it's a better approach to delete only your own traces from the audit log as an attacker. And the easiest way to do this for Oracle auditing is to use a comment in your SQL statement. So in every comment you can use the /* sign. And if you are using auditing, this entire statement is written into the audit log. So what we can do now is we delete every entry containing hack in the box. And then the rest is not modified, only our own statements is modified. One of the problems, if you run the delete statement against the audit table, the delete statement again is written in the audit log. To get rid of this, you must work as user sys, because every command from user sys is not written in the audit table. Every command from the user sys is written into the event log or in syslog. So after removing the traces from the audit log, we must delete the Windows event log. And here's some nice code, and from Oracle you can also run operating system commands. So the first step is you create a file containing the following code. It's a little bit big.
So in the PDF version, you will see the right layout. So here you see for each entry in entry log, we clear the event log. And then you have deleted the information from the audit table and then wipe out the event log on Windows. I already mentioned that many customers do not use Oracle auditing. They think, okay, it's better if you can control everything, and they developed their own auditing. It's quite common in large organizations. And to do this, they're using triggers. And in Oracle, you have different type of triggers. For example, you have a log-on trigger. Every time you connect to the database, the log-on trigger is executed, and in this log-on trigger, you can do something. For example, write the entire connect data to your own table. There are also DDL triggers, which are executed before or after running a SQL statement. There are error triggers, so whenever you are running an incorrect command, which throws an error message, you can call the error trigger. And trigger for custom tables. For example, if a user is modifying the salary of a user, you are saving the old value and the new value to a history table. So you have always the possibility to see what was done by what user. All the triggers are custom PL/SQL code, and every user and every customer is developing this in a different way. So you never know where's the table, what's the table name, and what is monitored. And in many cases, the information is sent to the DBA every 5 minutes. And now, deleting the Oracle thing is easy. But if it's an unknown database for an attacker, the question is, how can I delete everything within the first 5 seconds? And most of the audit tables are not storing the entire feature. They only store the old value and the new value. So the question is, how can we delete this in the script? And since Oracle 10G, there's a new feature, a new function called Aura row SCN. So on every table, in every data, you have a special value. And this value contains the sequence number when this data was created or modified. And now there's another table called SCN to timestamp. So you can convert this sequence number to a timestamp when the value was updated, modified, or created. And using this trick, we can delete information from a table where we do know nothing about column names and so on. And that's the way we do this. Delete from customer audit table, where SCN to timestamp. Here we retrieve the SCN number from every column, and we say delete all the entries which were created or modified in the last 5 seconds. And in most organizations, you don't see if there's a hole of 5 seconds. And this is normally a better solution than deleting the audit table. And this is how an attacker could do this. First, log on to the database and do a privilege escalation. If a customer is using a log-on trigger, you can ask the all trigger command and say, show me all database triggers, these are the default triggers from Oracle. They are available in every database. And the result is the name of the DDL trigger, if this DDL trigger exists. Now we can ask the database for the dependencies. So we can say, show us every table which is used by the trigger retrieved from the previous command. So we know we have a trigger called my super secure trigger, and this trigger is using a table name called dummy. And then we use the delete statement to delete everything which was modified, inserted, updated in this custom table we retrieved from the previous step. And that's a few lines of code, and can deal with unknown code as well. This was everything to auditing. If you want to design a good auditing system, it's important to understand also the point of an attacker. Quite often people are designing stuff without understanding how attackers are working. And this is, now we are leaving auditing and we are coming to a feature called transparent data encryption. Transparent data encryption is a new feature since Oracle 10G, and it's part of the advanced security option. Transparent data encryption means you can add encryption on table level. So it's possible to encrypt a table, and this transparent means if you come from the top level, everything in from the statement looks like unencrypted, but if you read the data file itself, everything is encrypted. The big advantage of transparent data encryption is Oracle is doing the key management for you. And the encryption keys to encrypt, decrypt everything is stored in an external file, or in 11G it's also possible to use hardware. And all the archive logs, redo logs are also encrypted, so if someone steals the archive logs, everything is encrypted. To use this feature, it costs only $10,000 per processor. That's one of the reasons most of the people don't have this. But in every installation, this is installed by default. So if you install an Oracle database, you have Oracle Advanced Security already installed. You are not allowed to use this without buying a license, but it's installed. And for auditors and for managers, this is a great feature. Because you can say, we are encrypting our tables using TDE, and all the credit card numbers are encrypted with AES 256. And for paper security, it's perfect. AES, check. But if the attacker comes from SQL or the application layer via SQL injection, everything is transparent, so it's not visible. Now we switch to view, and we are looking as a hacker to this feature. For the hacker, transparent data encryption is useful because it helps you to identify the interesting information. For example, a complete SAP system has up to 60,000 tables. The question is, you have no idea about SAP, where is the interesting information? If you are using transparent data encryption in a large system, you just ask the database, show me select table name, column name from DBA encrypted columns. And then you get a list of all the tables using encryption. And here you see there's only one table, so you know where the interesting information is coming from. As mentioned before, it's installed by license. To use transparent data encryption, you must set an encryption key, and if nobody did this before, Oracle is creating a wallet containing for all the encryption keys, and this wallet is protected with a password. And then there are two commands to create and also modify tables afterwards. So you can encrypt an already existing table. And the next time you start a database, the data is encrypted, so you must specify a password with the alter system set encryption wallet open authenticated by password. That's the feature. Now we switch and we have a different attack scenario. It's not related to Oracle, it could happen now to every one of you. Many of you are staying here in the hotel. What do you think will happen if the maid is taking your passport and puts this passport in the safe in your room? Many people here are not using the safe in the room, and then lock it with a key which is only known to the maid. And then she writes a small post-it saying, okay, for $1,000 you get the PIN. After this presentation, your plane is leaving in 2 hours. You go to the hotel room, check out, and you want to get your passport. but the password is in the safe and you don't have the key. Now there's a dilemma. What are you doing? Do you call the police? You must wait many hours. You will miss the plane. You need a new ticket depending on your ticket, and the ticket costs you 3,000 US dollar. And the insurance is not paying for this, or you pay the ransom. What are you doing? You have only a few minutes to decide. The good thing, here in the hotel, we have a back door. So if you have this kind of problem, you call the reception, say, could you open the safe for me? And they come with a master key and take everything out of this. Okay, now we try to migrate this scenario to Oracle. I mentioned it's installed by default in every 10G database. First, we break into the database and become DBA. If we have DBA privileges, we can use a feature like transparent data encryption. So we enable it by using this alter system command, and then only we know the password. And then we start encrypting important information. For the application, there's no difference between it's transparent and it's on coming from the application layer. The only problem is if you shut down the database and if you start the database. Or it's also possible to close the wallet. So in this case, an attacker could set up a database job which closes the wallet, and you can only open the wallet with the password. And depending on the backup concept, your data is in the database, it's not lost, but everything is encrypted. And only the DBA knows this password. And as far as I know, and I think from this design, there is no backdoor, because if there would be a backdoor, a master key to open the wallet, this feature would be useless. And now the question, what are you doing? Your managers are waiting because you cannot process the orders or something like this. What are you doing? An investigation takes ages, weeks, months, and it's unsure if you ever get your data back. Or do you pay the ransom? And you have only a few minutes or hours to decide. Another possibility, this could be a job protection from a DBA. So, okay, you know, in the next few months, there are some layoffs planned. Encrypted. You are responsible for starting up the database. Where's the problem? But what happens if you have an accident? So it's also, if you use this in a legitimate way, you must be able to guarantee that someone else is able to open the wallet. Mitigation is difficult because it's installed by default, and Oracle has no possibility to disable it. At least I found no way in the documentation. There's some workaround. There's an init aura parameter called compatible, and with this parameter you can say, I have a Oracle 10G release 1 database. And because this feature is not available in 10G release 1, you cannot use TDE. But the disadvantage, you can not use any other features of 10G release 2 anymore. Another workaround is, even if you do not plan to use transparent data encryption, you open the wallet and you encrypt nothing. But doing this is a license violation, and you must buy this. You must normally buy this piece of software. Another high security solution is called Oracle Database Vault. Just to hurry up a little bit, it's also a new feature since 10G, because Oracle is aware that security is a big advantage in the market, and customers are asking for this. And this is taken from OTN, so it's addresses the common problems like enforcing separation of duty, providing control who, when, where is accessing the data, and so on. It helps against insider threat, and it costs only $20,000 US per processor. So if you have a 16 processor machine, the Oracle sales person will be a happy man. It's also a great feature for auditors because, according to Oracle, it helps against PCI, SOX, HIPAA, and so on. and many people are using this to cover their assets. They say we are not interested if it's secure or not. Oracle says it helps, and that's sufficient for most of Pricewaterhouse and all these auditors doing mostly paper security. If you watch with the hacker view, I have 30 seconds, you must know Database Vault is a framework, so you must customize it, you must enhance it, and you must monitor every statement. If someone is unusual statement to do something, you will not detect this because you must really customize what is used. And from the concept, Database Vault can be disabled. This is necessary to apply security patches. And this is taken from the Oracle documentation. Just submit the following command, and then your $20,000 solution is disabled. Telephone. So you do this, and then you have an unprotected database, and the DBA can access again everything. So if you have users with operating system access, every user with operating system access as user Oracle can disable Database Vault. And most of the people are not aware of that. But it's the opposite to transparent data encryption. I would always have a possibility to enable and disable this, but it's difficult to control. And Database Vault, at the moment people are setting up these because it takes some time. It's often used in important databases. And if you are shutting down an important database, this creates a lot of noise, even if it's only a downtime of 2-3 minutes. And this is a scenario how you can shut down a 24/7 database without making this noise, without availability. If it's an important database, you have normally a storage system, and if you steal, you can steal data using a storage system. Normally you have 3 mirrors in a storage system, and what you can do is you split one mirror off, and then the Oracle database is still running because 2 of 3 disks are still available. Then you can mount this split away disk from the storage system on a new computer, and for the database, this new disk looks like a crashed database because you remove the processes without doing a proper shutdown. So you must do a recovery, and on the database is still running on your system. So even auditing is not affected, everything is working. Then on a separate PC, where you mounted this disk, you shut down the database, you disable Database Vault, start the database, export the data, whatever you need, and then you resync the disk. So even if you have auditing in the database, by resyncing the disk, you are wiping out all the traces. And you retrieve the data without downtime. And Database Vault is designed for insider threats. And the insider could probably do this. If you have a storage system, you must monitor who's doing what on the storage system. Summary, harden your database, passwords, apply the patches. First, do the basic stuff. If you really need security, analyze everything with SQL, external scripts, upgrade scripts, Perl scripts, ABK, and so on. Try to act like an attacker. You can come to my training to learn this. Attackers can often escalate their privileges to become DBA, even in a completely patched system. If you have DBA privileges, it's simple to bypass auditing. It's, in most cases, possible to disable security features, and where this is not possible, you can even abuse this functionality. That's the end of the presentation. Any questions? You can also ask questions later offline or send me an email.
Well, any questions? No? Going, gone? Well, if there are no questions, then thank you very much.